All right, so we're going to begin with Module 1, Part 1. Let me get all my windows in order. And we're going to start out with just some definitions, basic terms. And in the last part of this particular module, we're going to talk about a frequency distribution, and we'll get more so towards some calculator function type things. All right, so as we start off, there's two definitions that are pretty much the basis of the course. The first is the definition or the notion of a population. And a population is the complete collection of all elements. A sample is a sub-collection of the members of a population. If you're talking about a population, normally it's impossible to get 100% participation in a population. For example, the population of Aiken Technical College students. If we were to send a survey out to every Aiken Technical College student, we wouldn't get 100% response. You know, some people are just not going to respond. Some people may have moved, their addresses changed, that sort of thing. So it's normally impossible to get information about a population. And the census is a good example. You know, they send something to everyone's mail every 10 years. Hopefully the person fills it out, sends it back in with correct information. And then there's no people that unfortunately don't have an address, okay, to receive one at all. Okay, so that's population. And a sample is based on a subsection or a group of the population. And normally the sample is representative of the entire population. So that way when you make inferences or examples out of samples or deduce some information from samples, that same information should apply to the population. Okay. So as it says at the bottom, an important activity in this course is to demonstrate how we can use sample data to form conclusions about populations. So in the gist, that's the course. So here's some examples, and it says population or sample. The student body at Aiken Technical College, would that be a population or a sample? Population, right? Because it says the student body. The students in a statistics course at Aiken Technical College, a sample. Okay. Normally, if you're dealing with a sample, you'll see the word, this 10 randomly sampled students. They'll basically tell you if you're dealing with a sample or population. Now, just as far as some notations are concerned, you're going to see something that looks like this. And now my pen doesn't want to write. Okay, so I know that is very light. There is a way I can darken this up. Okay, I'm going to have to figure that out later. But you're going to see something that looks like this funny looking M symbol. Okay, there it is. This funny looking M symbol, that's read as mu. And that actually alludes to the mean of a population. And we're going to talk about mean, but mean and average are exactly the same thing. In some instances, they may say mean. In other instances, they may say average. But if you're looking at this funny looking M symbol, that is a population parameter. Now, as far as a sample is concerned, you may see something that looks like this. And this is read as X bar. And it's mainly a sample mean or a sample average. Right, so when we take a look at the computer or the calculator later on, we're going to see this X bar pop up. All right, so first two definitions are population and sample. The next two definitions are parameter and statistic. And a parameter is simply a numerical measurement that describes some characteristic about a population. A statistic is a numerical measurement describing some characteristic of a sample. Okay, so on this it asks which is a parameter and which is a statistic. So it says in New York City there are 3,250 walk buttons that pedestrians can press at a traffic intersection. It is found that 77% of those buttons don't work. Based on this would be an example of a parameter, simply because there are a total of 3,250 walk buttons. Even though they give you the 77%, it just says that 77% of the total amount of walk buttons don't work. But this would be an example of a parameter. Okay. The entire population of walk buttons is 3,250. For a statistic, and this thing starts out, it says based on a sample. So anything based on a sample is a statistic. So it says based on a sample of 877 surveyed executives, it was found that 45% of them would not hire someone with a typographic error on their job application. This is an example of a statistic because it's taken from a sample. All right, couple more definitions, qualitative and quantitative. And qualitative data can be separated into different groups or different qualities or different characteristics. Quantitative data is data that consists of numbers representing counts or measurements. So as far as quantitative is concerned, there is a number attached. So here's just some examples. If my daughter asked me for some allowance, I would say quantify, put a number to it, because an allowance could be 50 cents, it could be $1, it could be whatever. So if you say you want to lose some weight, you would have to quantify how much weight, right? So you're attaching a number, that means quantitative or to quantify. And then qualitative would simply be used to separate data into groups. So here's some examples. The gender of professional athletes, is that a quantitative or qualitative data measurement? Qualitative, right? Because gender is, there's no number attached to gender, right? So that would be qualitative. 2 says the weights of professional athletes. Is that quantitative or qualitative? Quantitative, right? Because you'd actually put a number to the weight of professional athletes. All right, so I'll just keep on going. All right, a couple more definitions are discrete and continuous. And discrete data, and we do have a math course that's called discrete mathematics. Discrete results in the number of possible values that are either finite, so finite means it stops, or countable. Like I'm able to count the number of people in this class, so the number of people in this class is a discrete variable, right? Continuous says that the results from infinitely many possible values. Now here's just a couple of things about continuous data. It's normally weight and time. So let me explain why weight is continuous. There are infinitely many numbers between 0 and 1. So what I mean by that is, I don't know how many zeros you're using. 0.000000001. That's between 0 and 1. 0.0000, I can add one less zero. That's also between 0 and 1. Okay. So technically, there are infinitely many numbers between 0 and 1. So if you think about weight, and if you're weighing something on a scale, that scale is only giving you an approximate weight. It's not giving you the true weight. Okay, because my true weight would be, let's say, 265 pounds. That's not my true weight. My true weight could be 265 and a half, or it could be less than 265. There are infinitely many numbers. So for continuous data, the main examples here are weight and time. And the reason why time is also continuous is because there's an infinite amount of time between like 0 seconds and 1 second. So what I mean by that is, let's say if you can complete a task in a nanosecond, a nano is like 1 billionth. 1 billionth of a second. So if you like round that and say, oh, I did it in a second, you actually did it in way less time than an actual second. Okay. So weight and time are considered to be continuous data. So here are examples. The number of eggs that chickens or hens lay, is that discrete or continuous? Well, you can actually count the number of chicken and egg lays, right? He's going to lay 1, 2, 3, 4, 5. So the number of eggs that a hen lays is discrete because it's countable, a countable set of eggs. However, the weight is something a little bit different. So the weight of the eggs that the hen lays is going to be what? Continuous. So if you just keep in mind, if you're asked if it's continuous or not, weight and time are always continuous, and normally everything else is discrete, a countable set. All right, now the last set of definitions we have, these are called the levels of measurement. And these are the actual levels if you had to listen from like 1 to 4. So the very first level of measurement is the nominal level of measurement. And it's data that consists of names, labels, or categories. So that is the lowest level of measurement. Okay, so notice there aren't any numbers attached in this. Okay, but if the numbers don't mean anything, then it could very well be nominal. We'll take a look at an example. The next up the level of measurement scale is ordinal. And ordinal data can be arranged in some order. All right, so for example, first, second, third, or fourth in a race, that's an order. Another order could be on that Likert scale, sometimes, always, never. So that's like a scale, even though it's like not like a numerical thing. It goes from like the most disagreeable to the most agreeable. Okay? So that's just like a scale or rank order. Then we have these last two, interval data and ratio. For interval data, the differences between any two values is meaningful. And for ratio, it says that there is a natural zero or starting point. So in order to determine between these two, for ratio data, zero means something. For interval data, zero doesn't mean anything. An example of interval data would be like the time in years, because 0 years doesn't mean anything. So like for myself, I've been employed at my current job, Aiken Technical College, for 23 years. So if someone asks you, how long have you been at your current job? 0 doesn't mean anything because you've either been working at your job or not, right? So for interval data, you should write down time is the main example of interval data. Also weather, that would be an example of interval data, because the 0 degrees mean that there's no atmosphere outside. That doesn't mean that it's like 0 weather. That just means that it's what? Cold. Right? So as far as weather is concerned, 0 doesn't mean anything. Okay, so it doesn't mean like it's an absence of weather. It just means that it's cold. For ratio data, there is a natural 0 starting point, which means that 0 means something. So let's take a look at some examples to explain all these. So here's some examples of nominal data. Surveys, yes or no responses, right? Those are categorical. Colors, those are nominal levels of measurement. Okay, categories. For ordinal, grades, A, B, C, D, there's a rank order, or anything with ranks, first, second, third, fourth, always, sometimes, never. Those are all an ordinal level of measurement. And next we have interval. So temperature is interval data because 0 temperature doesn't mean anything. It's not meaningful. Years are also considered to be interval data because 0 years, there's no such thing as the 0 year or year 0. And then for ratio, weights and prices, because 0 means something, right? You know, you can have something that weighs 0 pounds, technically you could. And you could have something that's free, right? The price is 0. All right, so now I'm going to bring up the handout. And there's just a couple of things on the handout I want to take a look at. And I don't know if the answers are on these or not, but we will go through them. All right, so the first question, we're dealing with parameter statistic. So the A says out of a sample of 977 men, so this, since this is already starting out as a sample, I know this should be a what? Statistic. Right, but it says out of a sample of 977 men, it was found that 67 like chocolate. That is a statistic. All right. B says using Consumer Reports, a random sample. So this is a what? Statistic. It says a random sample of new cars gave an average of 34 miles per gallon. Right, that is a statistic. C says in a recent sample, so this is going to be a what? Statistic. In a recent sample of 213 people, it was found that 19% do not bathe every day. So I wouldn't want to be around those 19% those people. Okay, what about the last one? It says 24% of vehicles sold are compact cars. Parameter, right? Because it didn't say anything about a sample. All right, number 2, we got to indicate whether qualitative, right, categorical type data or quantitative, which is a number value attached. So age and years, is that qualitative or quantitative? Quantitative, because age you have to attach a number. So that's quantitative. Okay. Think about the next one, the number on a soccer player's jersey. Now that one would actually be qualitative. And here's the reason why, because the number on the person's jersey doesn't really mean anything. I mean, the number one player with the number 1 on the soccer team, that doesn't mean you're the best player. And then the person with number 99 on the back of his number, that doesn't mean you're the worst player. Those numbers are just to categorize a name with the person. Okay. So now that was kind of tricky, but that is qualitative because the numbers don't mean anything. Whereas the age, that number means something, right? Okay, habits on always, sometimes, or never. Qualitative. Okay, what about the next one? The type of residence. Single family home, a bi-family home, a multi-family home. That would be qualitative. And here's the reason why. A single family home doesn't mean just one person lives in that home, right? I mean, it could be, but that person could have a spouse and a child, so it could be a 3 single family home, or it could be a 4 single family home. So type of residence is qualitative. So you want to keep in mind, even though in some of these instances there's a number attached, if the number doesn't really mean anything, then it's a categorical or qualitative type measurement. So that's qualitative. Let's see, match the level of measurement. Okay, number 3 is kind of split over into the next page, but it says match each variable with its level of measurement. The type of residence is that and I would go through them in order, right? Nominal is the lowest, ordinal, interval, and then ratio. So is the type of residence, is that a categorical or nominal type measurement? Well, it would be, right? Because single family home could either be one person or more, right? So the single family home is basically a category. So that is nominal. What about the number of children? So let's go through the order. Was the number of children nominal? No, it's not nominal because, if you got 5 kids, that means you do have 5 kids. Is it ordinal? I mean, well, you can't really rank order the number of children, right? You can just say I have 5 children, right? So it wouldn't be ordinal. Would it be interval? Well, now keep in mind, interval, does 0 mean something? Does 0 kids mean something? If you got kids, you know what 0 kids means, right? So then it would be what? Ratio. Because 0 means something, right? Not like years or time, right? All right, what about the number of years at a current job? that would be interval, because that's years, and 0 years doesn't mean anything. Right? So like if you were to ask me how long have I been in my current job, I'd have to give you a number because I'm currently at the job. Habits of always, sometimes, and never. Ordinal, right? That's a rank order. Okay, number 4 says describe which are discrete and which are continuous. The number of hours a student studied in 1 week. Well, remember when you're talking about continuous, time and weight are always continuous. Because let's say, okay, I studied 9 hours last week. Well, I mean, technically, I could have studied like 8.5. I could have studied like a little bit over 9. There are infinitely many values between 1 second and another second. So anytime you're dealing with time, time is always continuous, time and weight. What about wage per hour? That's discrete. Because your employer is not going to pay you a penny more than what they say that they're going to pay you. That's discrete. You can count that, all right? What about weight? Continuous. What about salary? Discrete. Because if you make $30,000, $40,000 a year, that's your salary, and you're not going to make anything less than that or anything above that. Okay, that's agreed upon amount. All right, so any questions about those definitions? What was which one? You said number 1, D. That was a parameter because it didn't mention the word sample. Okay, now I'm going to go back to the slides for just a second, and we're going to talk about a frequency distribution, and we're going to construct a frequency distribution from just a list of numbers. So first off, this is what a frequency distribution looks like. Notice here we have 2 columns. On the leftmost column, it just says data, so I'm going to add, let's just say this is the ages of people in a course. Just to kind of give it some context. And then we have the frequency or counts. So in this frequency column, that would give me the number of people in this age group, right? So as I read through this, it says from the age group 40 to 47, there were 11 counts. That frequency was 11. From 48 to 55, there were 18, so on and so forth. All right. So this is basically a frequency distribution. Now here's some definitions. Your frequency or count or tallies. So like if we were to do a frequency distribution, let's say in this class for men and women in different age groups, all right, we can separate it out in 2 columns. In one column we would have whatever we choose to have our data be. Okay, they didn't give this any context, but we will see some context when we construct our frequency distribution. And in the other column, you have the frequencies, which are nothing more than the counts or the tallies. So sometimes you may see some tally marks in this, like 1, 2, 3, 4, and then slash across with 5. It's just keeping up with the counts or the frequencies.
Okay, so you got the 40 and 47.
Right. So I'm going to explain what these things are.
Okay.
So we take a look at the definitions. First, there is the lower class limit. And the lower class limit is the smallest number that can belong to the different classes. So if I look back at this frequency distribution, my first this thing would have 1, 2, 3, 4, 5. It would have 6 classes. The lower limit for my first class would be 40. The lower limit for my second class is 48, and so on and so forth, right? So the lower limit for my sixth class would be 80, right? So the lower limits are on the left-hand side. The upper limits are the largest number that can belong to a different class. So taking a look back at the frequency distribution, the upper limit for my first class is 47. The upper limit for my second class is 55. For my third class is 63, and so on and so forth. So that first number is the lower class limit. That second value is the upper class limit. Next, we have what is called a class midpoint. And the class midpoint, it's not actually shown here, but in order to find the class midpoint, and we're going to see an example of this, you would simply add the lower class limit plus the upper class limit, and you would divide by 2. Right? So let's just say if I wanted to find the midpoint for my first class, I would take my lower limit plus my upper limit, and I would divide by 2, and that would give me the number that's in the exact middle of the lower class and the upper class. Right. So we take the lower class plus the upper class. I'm going to write this out. And we divide by 2. So give me 1 second. All right, so in order to find the midpoint, we have to take the lower class limit plus the upper class limit and divide by 2. Okay. So that LCL, that's just the lower class limit. That UCL is the upper class limit. So we add them and divide by 2. All right. So we're going to take a look at that in an actual example. All right, so that's the class midpoint. The next definition is the class width. To find the class width, you must find the difference between 2 consecutive lower class limits. Okay, so let me explain this class width. If I go back to the frequency distribution, now a lot of times when you calculate the class width, you simply just want to take the lower limit, the upper limit, and subtract them, right? But you do not find the class width that way. You always want to be 1 short. In order to find the class width, you can take the lower class limit of 1 class. So say if I take the second class, it has a lower class limit of 48. That's right. As long as they're consecutive. Consecutive means back to back. And then if I take the lower class limit of its consecutive, so I'm going to go back 1, so that's 40. If I subtract those two, that's what gives me the class width. So the class width is 8. Normally what some people will do is they'll say, well, it's just 47 minus 40, which is going to give you what? 7. You're going to be 1 short. And this is why it's something called the counting principle. So if I'm going to count this on my hand from 40 to 47, so I have 40, which I have to include, 41, 42, 43, 44, 45, 46, 47. So that's a total of how many numbers? 8. I'm not going to get 8 if I just subtract across. You want to either take the lower class limits or you can subtract the upper class limits. So like I say, if I subtract 55 minus 47, I'm going to get 8. Never subtract going across to find the class width. Is everybody okay with that part?
So then we count from 47, 48, 49, 50, 1, 2,
54, 55, and that will be another 8 numbers. So those 8 numbers give you that class width of 8 numbers. So to find the width, you either want to subtract consecutive lower limits or consecutive upper limits, but you never subtract the upper class limit and the lower class limit because you'll always be like a number short. Yeah, I'll write it out. To find the class width, subtract either consecutive. So consecutive, I mean they have to be back-to-back classes. Consecutive lower class limits or consecutive upper class limits. Okay, but never go across to find the class width. All right, so any other questions about class width? Because you're going to be asked that. All right, next we have a relative frequency, and the relative frequency is found by dividing the class frequency by the total of all frequencies. We're going to see that in action when we complete our frequency distribution. All right. And then the cumulative frequency is the sum of frequencies for that class and all previous classes. So we're going to see all of these things in this example. And on the handout, okay, that very last problem, okay, this is our problem. And I actually have it on here so I can write on it. It says calculate the class width of the data, of this data, and construct a frequency distribution for the data set using 6 classes. Enter the lower and upper class limits of each range in their respective boxes, and then fill in the corresponding frequency. Right. So you will see this on the test. All right. And I believe you do see it in the homework. So they just give us this blank data set, and they tell us to make a frequency distribution using 6 classes. So they don't give us like the class width or anything. Okay. So here are the steps we're going to use. The first thing we have to do is construct a frequency distribution. Okay, the first thing we want to do is calculate or find the class width. So here's how we want to find the class width. And here's the formula for that. We have to take the lower class limit plus the upper class limit which is that max value minus the minimum value divided by the number of classes. So what I have to do in order to find the class width, I have to find the maximum value or the largest number in this data set. I have to subtract from that the smallest value from this data set. And then I have to divide by the number of classes. And in this example, they want us to use 6 classes. So that is the first step, is to find the class width. So now I'm going to bring up the calculator, and I'm going to use the calculator to organize some of this data over here. So what I'm going to attempt to do is I'm going to put this data set into the calculator. Once I put it into the calculator, I can put it in order from the largest to the smallest or the smallest to the largest. And once I get it in order from the largest to the smallest, we'll pull out the minimum, maximum, we'll find the number of classes, and then that'll help us better calculate the frequencies. All right. So in order to put the data into the calculator, I'm going to write some steps over here. Give me 1 second. To put the data set into the calculator, first thing I want to do is just turn it on. And I'm going to just, whenever you hear me say home screen, that's this blank screen of the calculator. You can access it by hitting the second key and the quit key. All right, that's the home screen if you ever hear me say that. Okay, so once I'm in the home screen, so we want to go to home screen. You want to hit second and mode to do that. I'm going to hit stat, S-T-A-T. And once you're in stat, you see these things on your calculator. You see something to the right that says calculate, something to the far right that says test. We'll get into those a little bit later. In order to enter data into the calculator, I simply want to hit this number 1 edit. So this is enter data into the calculator. Yeah, so you want it, once I'm at the home screen, so I'll go back. So I'm at my blank screen. The next thing I do is I hit stat. And then you want to choose that first option, which is edit. All right, and once you hit enter, it pulls up these lists. There should be a total of 6 lists. So if I scroll across, that's list 1 through like list 6, right? If you're seeing, sometimes your list can get out of order, right? Sometimes you may not see list 1, you might see list 2 and list 5, they may get out of order. If your lists are out of order, you can reset your list. But for our purposes, is everybody seeing like list 1, list 2, list 3? If you're not seeing that, just raise your hand. I'll show you. But that is list 1. I got it. All right, so let's just say if you have some numbers in your list. Let me go back. So let's just say I got some some numbers in one of my lists. You can hit delete and delete them one by one. Or if you go to the very top of the list, so notice I'm going up to the very top of my list where list 1 is highlighted. If you hit clear and enter, that'll wipe out all the numbers in your data set. All right, so what I'm going to do at this point is I'm going to enter these numbers into list 1. Just be mindful that after you place your number in, you want to hit enter. So I'm going to put these numbers into my calculator. I'm just going to put them in going across, and then I'm going to sort them in a second. Right. So as far as my steps are concerned, you go to the home screen. To put the data into your calculator, you hit stat, then you hit number 1 edit, and then you should start putting your numbers in. Right. So I'm going to put in 13, enter, 40. And unfortunately, there isn't another way to get these numbers in. You have to manually put them in. All right. So I think I got them all in. I'm just going to check them. Now, you see on my calculator, like on my last number, it says L1, and then it has this 20 in parentheses. That just means that there's 20 numbers. Okay. So now I'm going to check them just to make sure, because if you put in the wrong numbers to start with, it will definitely give you the wrong answer. 34, 14, 31. Okay, I think I got everything in. 48, 35, 46, 37. Okay. All right. All right, so we put everything into the calculator. Okay. Now, the third thing we're going to do is I'm going to return to the home screen. Right. We're going to return to the home screen a lot, and you're going to see that. We'll go into the statistics, put some numbers in a data set. You must perform all of your calculations in the home screen. Right. So I'm within the stat now. I put all my numbers in. The next thing I'm going to do is return to the home screen. So I'm going to hit second and mode. And this may seem like a lot, but this makes the work a lot easier as far as tracking these numbers down, because there is something called human error. Well, if you stare at some numbers long enough, that 7 may start to look like a 1, the 5 might start to look like a 2, but if you put it in the calculator, you can avoid that human error. All right, so I went to second and mode, which is the home screen. And now I'm going to sort the data set. Okay. So in order to sort the data set, I'm going to go back into stat. And then if you notice under this edit, you have this second option says sort A, or I can put it in an ascending order. That's from the smallest number to the largest number. You can put it in descending order. That's from the largest to the smallest. And then there's something that says clear list and setup editor. I'm going to put my list in descending order. So it's going to give me those numbers from the smallest, from the largest to the smallest. So I hit stat, and I want the third option, which is sort D, which is sort in descending order. I want to hit enter. Now you have to tell the calculator which list you want it to sort. So remember, we put everything in list 1. So if you look at your keypad, you'll notice above the number 1, at least on my calculator, it's list 1 and it's yellow. So I don't recall that list 1, so I'm going to hit second and 1. Right, so that's the list I want to put in descending order. I'm going to close off my function, and I'm going to hit enter. So to write that out, what I just did, I hit stat. Let me just go back from the beginning. I hit stat. I went down to the third option, sort D. I hit enter. Then I hit second and the number 1. And this gave me L1, right? So I hit second and 1, and it popped up L1. And then I close off my function. So that was the end parenthesis, and then we hit enter. Okay. So once I hit enter, it's sort of like it didn't do anything, right? It says done. But if you go back into the list, so this is the 5th step to view the sorted data. Okay, you go back in the stat. So I'm going to hit stat. I'm already on the home screen, so I'm going to hit stat. And then I'm going to choose this first option, which says edit. And then notice that your data set is now in order from largest to smallest. Is everybody okay with that? That says stat. So I'm going to go back. If I'm at the home screen, and if I hit stat, and then if I hit this edit, that's that sorted list. So now I can kind of easily pick out the largest number. I can pick out the smallest number. And then once we find these classes, we can go ahead and do our tallies. All right, so let's go ahead and construct this out. So we're going to have our classes over here. we're going to have our frequency over here. We also have to find the midpoint. Right, because this thing says enter your class width. We're going to find that. Then it says you have to find the class range. So we're going to put the class ranges under this class column. We're going to find the frequency, the midpoint, the relative frequency, and the cumulative frequency. Oops. All right, so is everybody with me? So that's 1, 2, 3, 4, 5, 6, because we need 6 classes. Right. I'm trying to shrink it down. I can get it off. Okay. All right. All right, so basically what we did up to this point is we talked about the formula to find the class width, which we're going to use that formula now. We put the data into the calculator. We put it in descending order. So now let's calculate the class width. So what is the maximum value? 56 minus what is the smallest value? 11. And we're going to divide that by what? 6, because it's 6 classes. So 56 minus 11 is 45 divided by 6, which is 22.5. Is that? Let me check that. Okay, 56. Okay, now if you're using a calculator, you want to be careful. 56 minus 11 divided by 6, we get 7.5, right? Okay, now here's the thing. Whatever number you get, you have to round that up to the nearest integer. So remember, from algebra, the integers are your negative and positive whole numbers. So I'm going to make this 7.5. I'm going to round that up to 8. Is everybody okay with that? There is a problem in the homework. When you find this class width, you're going to get 10. You have to round that 10 up to what? 11. Is everybody okay with that? You always have to move up one integer, no matter what number you get. So let's just say if I would have did my math and I would have got 10, I would have had to round that up to 11. So you always move up one integer, always. So just keep that in mind. All right, so our class width is 8. So now when we fill out our classes, remember that the class width, I have to subtract either the lower class width or the upper class width, right? So if I go to my smallest number, so I'm going to put this in the classes from the smallest to the largest as far as numbers. My smallest number is what? 11, right? So let's say if I go all the way down, I got 11. That's my smallest number. That's where I'm going to start at 11. What would be the lower class limit for my next class? Well, my class width is what? 8. So 11 plus 8 is what? 19. Okay. What's the lower limit for my next class? I just got to add 8 more, right? So I get 27, 35, 43, and 51. So those are all my lower limits, right? What's going to be the upper limit for my first class? 18, right? Because the next class begins at what? 19. So that means that my first class must end at 18. So now I can just keep adding 8, right? So 18 plus 8 is 26, 34, 42, 50, and 58. So now you'll notice that my largest number is 56, not 58. That's going to happen, right? Because you always want your last lower class limit to never be the last. I mean, if it mathematically works out that way, then that's how it works out. But normally that very last upper limit is going to be a number that's outside of your data set. So any questions on the classes? So just to recap, we put all the information into the calculator. We put it in order. We found the class width. So we took the largest value minus the smallest value divided by the number of classes. And then we had to do what? Always round up by 1. All right. So no matter what your number is. So then we took the smallest value in our data set, which was 11. From that 11, we added 8, which was the class width, and that gave us the second lower class limit, and we just proceeded, right? So we found all the lower class limits, and then in order to find the upper class limit for that first class, we just simply subtracted 1, right, from this upper class limit of 19, all right, and then we added accordingly. Now we have to find the frequencies. So remember, the frequencies are the counts. So this is a good reason to put this in order because it's easier to count the number of numbers between 11 and 18 using this organized set of data versus this. Right? Not to say it can't be done, but I think it's a little bit easier to find the counts this way. Okay. So if we fill in our frequencies or our counts, how many numbers are either or between 11 and 18? Looks like 1, 2, 3, 4, 5, right? So that frequency is 5. How many numbers between 19 and 26? It looks like 1, 2, 3. So my frequency count is 3. Yeah, you have to include 19 and 26 if they're. So I have 19, 23, and that's 25.
Okay, tell me how you have 5
Okay, I got 5 because if I look at my data set, I want all the numbers between 11 and 18, including 11 and 18. I got 1 number, 2, 3, 4, 5.
So I thought with the frequency, if you're just not looking at a calculator. So okay, so on the data set I put at the end, it was 40 and 47, and the frequency was 11. And you count 40, 41, 42, etc. to 47, and you got 11. So wouldn't that make the frequency of 11 to 18 like 8?
It's based on
the number of numbers within that range. So like from 11 to 18, I got to include 11 and 18 and all of those numbers in between. So that would be a total of 5 numbers, right? Because you would have 11 as one of the numbers, 13 as a second number, 14 as a third, 15 as a fourth, and then 18 would be your 5th number or your 5th count. Okay. Or if you're using this chart over here, you could go in and like cross them out. So what I mean by that is like we use 11, we use 13, we use 14, and there's like 15 and 18, right? Which is 5 numbers, 1, 2, 3, 4, 5. For 19 through 26, there were a total of the 3 numbers. There was 19, 23, and 25, right? So that means that there were 3 counts within that group. For 27 through 34, I got to use 28. So that's 1, 2, looks like 3 numbers again, right? So that is 28, 31, and 34. For 35 through 42, looks like 1, 2, 3, 4, 5 numbers. Oops. So that would be 35, 37, 40, 41, 42. For 43 through 50, it looks like there are 2 numbers, 46 and 48. (46, 48), and then between 51 and 58, there's 2 numbers left, right? 53 and 56. So this is our class ranges along with the frequencies or counts. So you must include those, the lower class limit and an upper class limit within the counts, okay, if those numbers fall there. Are any questions about the first couple of columns? All right, so now let's find the midpoint. So there is a formula for the midpoint. It is the lower class limit plus the upper class limit divided by 2. Bless you. So the midpoint for the first class, I'm just going to add 11. Now, when you're using this calculator, be careful because you have to make sure it's following the order operations. So if I had 11 plus 18, I got to hit enter. Then I'm going to divide by 2. If I put it all in one step, I would use a set of parentheses. And I should get the same answer. You never want to put it in as 11 plus 18 divided by 2. Because what your calculator is the order operation, and it's going to divide 18 divided by 2, and then it's going to add 9, which you do not want it to do. So if you notice, when I'm doing this stuff up here, I'm mainly using 2 steps. Like I'll take 11 plus 18, I'll hit enter, and then I'll divide it by 2. All right, so just be careful when you're using that calculator. So the midpoint of our first class is what? 14.5. Right. That's right. And then it spit the answer out. Hit enter. That's right. That's right. That's right. So now we can find the midpoint for the next class. So I can add 19 plus 26. All right, I'm going to hit enter. Divided by 2 is 22.5. Now, could I do something else? I could add the class. I could add 8, right? So what I mean by that is, if I go back to the beginning, right, I found that first midpoint, 14.5. If I add 8, which is the class width, that should give me the next midpoint. And now I can do what? Add 8 again. That's 30.5. If I add 8 again, 38.5. If I add 8 again, 46.5. And if I add 8, that's right. You can add that class width. Or you could just simply add that lower class plus the upper class and divide by 2, right, for each one. All right, so any questions so far? All right, now let's find the relative frequency. So there was a definition for the relative frequency, and I'm going to go back to those definitions. And it says that the relative frequency is found by dividing the class frequency by the total of all frequencies. So if I go back to my frequency distribution, I have the individual frequencies, right? I can find the total frequency by doing what? Adding all that together. We're looking at the calculator, so we should have a total of how many numbers? 20, right? So if you add 5 plus 3 plus 3 plus 5 plus 2 plus 2, that should give you 20 numbers, right? So you're going to need that 20. That is the total frequency. So the relative frequency says I have to divide the frequency for that class by the total frequency. So in order to find the relative frequency for the first class, I'm going to take the frequency for that class, which is 5, right? And I'm going to divide it by the total frequency, 20. Right? So 5 divided by 20, that gives us 1/4 or 0.25. Right, so that's 0.25. To find the relative frequency for the next class, I'm going to take the frequency for that class, which is 3, divided by the total frequency of 20. So 3 divided by 20 is 0.15 or 1500ths. The relative frequency for that third class is 3 divided by 20, right, which is the same. 20 is that total. Yeah, 20 is the total frequency. Right. So the frequency for the next class is 5 divided by 20, right, which again is 0.25. The frequency for that fifth class is 2 divided by 20. Right. So it's going to be 2 divided by 20 for those last two classes, right? Mm-hmm. So you should get 0.1. I mean, so not too difficult, a little bit time consuming with all these numbers, but all right. Now the last column is the frequency distribution. And it says that the frequency distribution, cumulative frequency, is the sum of frequencies for that class and all previous classes. So it's the sum of frequencies for that class and all previous classes. All right. So if we take a look at the first class, the sum for that first class is 5, right? There is no previous classes to add to it, so the cumulative frequency for the first class is 5. The cumulative frequency for the second class, it has a frequency of 3, but you have to add all classes prior. So 3 plus 5 is 8. All right. So the cumulative frequency for the next class is 11, right? So 3 plus 3 plus 5. All right. Or basically, I'm taking 3 plus 8 because I already got it summed up over here. The cumulative frequency for the next class is 16. That's right, from that class and all of the classes prior. So then we have 18 and 20. It all should add up to, that's right, how many numbers you start with. All right, so any questions about the frequency distribution? Now, in the next module, to jump ahead, we're going to talk about a probability distribution, and it's much the same as a frequency distribution, but instead of dealing with frequencies or counts, we're going to deal with probabilities, right? But the buildup is much the same.